now we've reached the final presentation of our summit. It will be a panel discussion that looks at how maintenance software helps your bottom line. Looks to be a good conversation. We have a great cross-section of participants. They are Stephen Shirley, President of Farstar SAC Consulting, Stam Shantz, Co-founder and Vice President of Perspect Analytics, Steve Richmond, founder of Project Tech, Michael Cooper, Solutions Engineer, Fix Software, and Matt Lindsay, Client Manager at RT Tech Software. This discussion will be free-flowing. We'll try to see how maintenance software can help a company's bottom line. If you have any questions that you want us to cover during the conversation, please post them in the questions box. We'll try to get as many questions that time permits, and all panelists will get the chance to speak. For fairness, alphabetically, our first question will go to Stephen. Okay, Stephen, so the first question is, what will the system give me that I don't have today? If I decide to upgrade, how much will a maintenance software system cost to acquire, implement, and maintain?
So I'll start with the first part of the question, which is what will I gain? And I assume we're coming from a manual or possibly, a system that's just maintained in something simple like Excel or Microsoft Access. So I think the biggest thing that you're going to gain first off and foremost is the work order management capability, the ability to plan your preventive maintenance and see the timing of when that's going to happen. And if you have ideas of how much of your maintenance team's time is involved in each of those preventive maintenance events, you can start to see a schedule for your team so you can make sure that they're available and ready to work. And you can also try to now schedule back into the shop and let them know when that preventive maintenance is going to be done so that you can plan around it and maybe reassign people to other work. But the other thing that comes along with a CMMS is the inventory and purchase order management side of things. I mean, we've talked a lot about some great technology today, but at the end of the day, we need the right part at the right time. So when something goes down, we need to make sure that we have the parts available so that we can actually carry out the repair or the maintenance that we were planning for. But over time, the big win and I think the big benefit, and it came up in some of the presentations that we heard earlier today, is you're going to build up the data so that you can do analysis. You can start to see trends. You can start to see do your 80-20 analysis on specific pieces of equipment and see what your material usage is. And the other thing you can do is to build up the costs of maintaining or repairing specific equipment. So when it comes time to go to your board of directors or senior management team to ask for money for possible new equipment or upgrades, you've got a basis of fact to help drive the decision. In terms of cost, that's a pretty broad question. There's lots of different applications. There's many of them on the market, and they have a wide range of features. So the cost range is pretty broad, but it can start as low as a few $100s per year per user, and it goes up from there. And if you buy a perpetual license of one of the higher end systems, you're going to be talking about a few $100,000 of investment. So it's a pretty broad range. I think the important thing, and it came up again in some of the earlier conversations, is to select the right functionality and the right software that you need for your business. So what right featured, and I would suggest maybe right sized. So don't over specify what you need. Just make sure you're getting the things that you really need to focus on and have a solid selection process with a defined business case and some specified needs, like a matrix that you could check off and say, these are the things that we feel are critical to the business, and they are or they are not present in the solution that we're evaluating. Otherwise, it's too easy to get sidetracked in something that looks really neat, but maybe isn't delivering what you really need.
So this one's for Mike Cooper. Labor is one of the biggest costs for maintenance teams and companies in general. How does maintenance software help reduce labor costs and get more value from the labor that is being used?
Yeah, that's a good question. I think, a lot of the high level points have kind of been touched through the various presentations and even from Stephen's comments there just a minute ago. But I think, looking at from a very, entry level, moving out of Excel, moving out of the clipboard or the whiteboard, corkboard model of running maintenance and getting into an organized system like CMMS, that helps you save save your costs simply by just being more organized, at a very basic level. Like, I don't know how many times I've come out of as a maintenance lead, as a supervisor or manager, you're in a meeting, you're expecting work to be happening out on the shop floor, only to come out of the meeting and you find out none of it was done. The excuse often is, well, you didn't give it to me. You didn't assign it to me properly. So I didn't know it was me that was supposed to be doing, this work. So, maybe that work was, a critical PM or a safety check. And, now you're paying overtime to get that work done. So having a CMMS allows you to kind of take, those preventative maintenance work or even reaction maintenance work, assign them to specific people and know that they're correctly delegated. Also out on the shop floor, I don't know, maybe it's just me, but like, I don't know how many times I've been out at a breakdown, it's 3:30 in the morning, you've, an automotive industry, you've dropped a car in the e-coat tank or something, and you need a specific set of tools to help get you out of that situation. And maybe that's an extreme situation, but oftentimes you run into, hey, we don't have this set of drawings, or we don't have this machine ledger, or we don't have a list of spare parts, and we end up waiting for a tech. We've got to call a specific tech because that single tech is the one who knows, right? Who knows the drawings or knows how the machine works. And, that can be highly costly being in that situation, and how a CMMS kind of helps you overcome and empower your techs a little more are, simply by having all those files available within the machine or asset record in the CMMS. So, imagine that same scenario where, you might have depended on a single tech to just know how to fix that problem. The other techs really aren't eager to jump in because, drawings have been lost, or they don't have access to schematics or things. Imagine a different scenario where you're using a CMMS properly. Tech pulls the cell phone out, scans the barcode on the side of the machine, and they instantly have all of those files, right? They can pull the PDF up with the wiring diagram, or they can pull an old copy of the PLC program up, or, the machine ledgers, or dive into spare parts lists. And, even as far as, where are those spare parts located? What are my inventory? So now, we're going to the right tool crib to get the parts, rather than waiting for a tech to walk all over the shop floor and find that one spare part that, someone hid in their toolbox. So at a really high level, I think organization helps improve the bottom line and reduce costs. But getting in a little more granular, when you start looking at how a CMMS system can help you get into more condition-based maintenance. So, rather than say, hey, we just lube this machine, every other week till the end of time, because that's just what we've always done, right? Or that's just what has worked in the past. We can start looking at getting involved in condition-based maintenance, meaning, we pull in data from, say, the PLCs, or the robots, or the CNCs directly into the CMMS and say, yeah, it's been 2 weeks, but we really only need to lube this waste bearing on this robot every 100 hours. Have we got to 100 hours? No, right? So let's wait until that 100-hour trigger is hit, and we do the maintenance then. So very quickly moving into that condition-based model using the CMMS, we can start getting into reduction in maintenance costs by reducing the over maintenance of machines. And then finally, looking at, reporting abilities. Like a good CMMS system should have a good analytics and reporting tool available. So all this data we're capturing, it doesn't follow the old model of, let's just write it down on a piece of paper, put it in a clipboard, hang it on the shelf on the wall, and we never pull it out until the auditor asks for it. Right now, the data is available to consume. So a good analytics and reporting platform is really good. A good tool to help reduce costs by allowing us to aggregate the data and think Miguel talked about it quite a bit at the beginning of the presentation today, being able to kind of get into those Paretos or stratification of losses. So you can very quickly start stratifying what machines are my biggest losses, what area in the shop is my biggest losses. If you're at the director level, which site, across all of my sites are the biggest offenders, right? Do I have one site that's quite a bit worse than another? Do I need to share best practices from a better performing site? So right away, we get better insight onto where we need to focus attention and resources to improve uptime, reduce costs. We get technicians more organized. They're now focused on the right things and start getting into condition. One final point I'll make, and this has been a topic of a number of people today, is getting into kind of the AI and machine learning, getting beyond even condition-based maintenance and getting into kind of predictive based maintenance. You start looking at some tools like what we call asset insights, where we start looking at, how often are work orders being generated against a specific machine? How is parts consumption increasing on a specific machine? Are regular labor tasks against that machine all of a sudden starting to take longer, and start using artificial intelligence algorithms to start highlighting that, hey, yeah, maybe this machine's uptime is still fairly consistent, but we've got all these other red flags going on in the background that, point us towards there's something else going on with this machine. Maybe on a Sunday when we're not running production, we should go in and do a bit of a deep dive on the machine and go and see what's going on, just to try and avoid downtime during those critical production hours. So I think those are 3 or 4 points that really lead us to look at how a CMMS can help reduce costs.
All right. Anybody else want to chime in on how maintenance software can help reduce labor costs?
Sure, I'll chime in on that one. That's one that I've been focusing in on for a long time in my career. One of the things that, if anybody's had any opportunity to try to hire a tradesman these days, it's pretty tough to try to hire somebody.
Very
so
difficult.
What we can use, and we don't think about this, but our systems that we already have in play, like our CMMS, like our IoT setup, we can use that information and draw it from the tradesman. Get that information out of their heads and into a software system. That saves you so much money. One, it creates a scenario where now it's not sitting in the tradesman's head. It's sitting out there, truly there, where you can start to use it and analyze it. Number 2, because of COVID, a lot of the older ones, gray-haired ones, are sitting there and decided to retire or are going to retire. And there's nobody in the background to replace. So the opportunity to train somebody and take that 6-month window to train somebody is disappearing. So now you can use your software with that train of thought in mind to get them. And there's different strategies that we've used in organizations to do that, to putting together some teams in which their goal is to document their experience on key pieces of equipment, get it into the system. But if you can do that before it leaves, now your software systems, your CMMS, your IoT things, your troubleshooting pieces are all there now ready to go, so that you lower your training side. And when you find that you're going to be minus 3 tradesmen, you got a lot of 50 tradesmen, but you know what? You can't hire them. So you got to run at 45. Mm-hmm. Now that's going to be extremely beneficial.
Absolutely. You get those critical kind of task lists against specific machines on standardized work built in. You get parts lists associated with all those tasks. Absolutely. Completely helps streamline the process and get new technicians kind of up to speed quickly. That's a very good point.
I find a lot of this is done very manually. So having a CMMS to be able to collect a lot of that data, automate a lot of those processes can really better utilize those resources. You're talking about it, Stan. It's really hard to hire people. Hiring them, then getting them to do manual recording or to do paperwork and data management, it's not a great use of their time. So putting in these types of systems and trying to automate as much of that process as possible really frees up them to do the $100 an hour work instead of the $10 an hour work. really getting more value out of those resources.
Yeah, I agree with you totally there, Matthew. And the other aspect of that is the demographics are shifting. You bring a 30-year-old and you tell him to sit down and do that manually, he's not going to be around for very long. So they're expecting that. They're expecting to have the technology. They've been raised with the technology, and they expect to have the AI experience, right? That robotic experience. So you have to give them the tools to keep them and retain them. And what a better way to do it than just have them absorb their information into the software as you move forward.
Mario, I think it's important for people to understand the difference between reactive work and planned work as well. And good systems will give you that capability. It's inevitably more expensive to do unplanned work than planned work. If you have a certain window of opportunity to make sure you have the right skills, the right information, the right trades, parts, tools, materials, access, all of those things go into a planned job, which will eat an unplanned job's lunch in terms of efficiencies. And a good system should allow you to bring all those things together. I think a good definition in any environment as to what is planned and what's reactive is very important to understand, and a very good discipline to adopt. If you can make everything possible planned work, the efficiencies that come from that are tremendous.
Yeah. And I think a good way to make that transition from unplanned to planned is having a good CMMS to capture all of those unplanned events, look at patterns on, maybe you've got a bunch of reactionary work happening for a similar failure mode over and over again. So you can start looking at what are the conditions that led up to that failure mode. Was it, we ran the machine too long, we under maintained the machine, are we using inferior parts? Try and identify those failure modes and then work that into your preventative maintenance schedule to, address those failure modes just prior to them actually turning into a failure, during production hours or an unplanned failure. If you've got all that history in your CMMS with a good reporting system, obviously I think it makes it quite a bit easier to kind of look at those patterns, find those kind of needles in the haystack and say, okay, this is kind of the predictor for this machine to failure, or here's the time frame we can realistically believe this part will last in these conditions, and start building your preventative maintenance triggers off of those predictors.
I agree, Michael, and I think that information sync, whatever kind of system you have, the data that you can glean from it, non-planned work begets more non-planned work. If you study what's not planned and understand why it's repetitively being unplanned, you'll find a way home to reduce that stuff tremendously.
Yeah, I agree 100%. And I mean, the worst thing to me, I don't know if this happened to anyone else, but half the time unplanned work, you go in and fix whatever broke, and you're usually in a rush. You got, production breathing down your neck, or the plant manager tapping his foot beside you. And what always happens, we go in and we fix the problem, and something else breaks right beside it. We didn't notice, or there's, some unplanned failure. We over torque a bolt, or who knows, trying to get in and out of there quickly. And then now we've got a secondary failure, and to your point, if we could have, addressed that earlier, or during, non-production hours, we'd have never incurred the original failure. And then the secondary one that by accident, maybe we created by simply going in there to fix the original.
I completely agree. I think more often than not, emergency work merely eliminates the symptom. Very seldom do we have time during emergency work to get the root cause.
Agree 100%.
Yeah, it's one of the main reasons that we try to have a planning and scheduling article in almost every issue of MRO. So, all right, we'll move on. This one's for Matt Lindsay. How can downtime tracking systems lead to greater asset reliability? In turn, how can we use the KPIs generated from downtime tracking systems to drive improvements?
Yeah, I think downtime tracking systems are really the first line of defense. And it's been said before, if you can't really improve what you aren't measuring. Knowing what is stopping your machines is really the first step to preventing it. These downtime tracking systems in a lot of cases can be configured to capture real-time data from like your SCADA, your control systems, or your process historians, really to identify the operating conditions for any asset in the plant. This could be the running status, or at its very simplest, or its operating conditions that are happening in real time. They can also grab and leverage a lot of the motor drive fault codes, some system interlocks, or any programmable logic in the system to then auto code a lot of those events with reason codes, which kind of eliminates the need for an operator to have to manage it. This can really provide a greater insight on what drives each asset stoppage and can feed the asset health analytics in your CMMS. Really reviewing and analyzing that data is ultimately what will lead to identifying solutions, which will hopefully prevent that downtime from happening again in the future. That should result in a greater reliability for your assets. That downtime tracking system can also allocate the events into different time classifications. These classifications are then used to calculate time-based KPIs. These KPIs can be useful for like gauging the performance of different groups in a production team. A handful of KPIs like availability or mean time between failures, they can really indicate how effective the maintenance strategy is and really the maintenance team as a whole. When those assets are kind of mechanically, electrically available, KPIs like utilization or use availability can start to reflect your planning team's ability to supply operations with the raw materials and utilities that they need to operate. And then KPIs like operational efficiency or productivity, mean time between stoppages, those really show how your operating team can perform when they're given the assets and the materials they need to produce. Really, all that data collected in a downtime tracking system can provide insights that are really actionable by any one of those three groups. And the KPIs should show over time how successful those improvement initiatives have been. Ultimately, those KPIs will reflect on those different groups in a production team and act as really a key metric to monitor the effectiveness of the maintenance and operating strategies. And what I've found in my experience is that the individual groups and the people in those groups end up owning those KPIs and really try to strive to improve upon them.
All right. Anybody else want to talk a little bit about downtime tracking systems?
Sure. One of the things that we found with having an artificial intelligence and machine learning platform and a hub is that data that comes from directly from the equipment, it's so valuable to truly understanding how efficient your business processes are. Because what it does is it tells me the exact time the machine was down, but there's planning ahead of time, there's cleanup afterwards. So now I can see the entire window and truly understand my execution. I can truly understand now and link it to my plan and how effective that plan was. There's so many things you can do with just that little bit of information. You know, I mean little, because when you look at the big scheme of things, it's only grabbing the start stop, or it's grabbing certain information about quality once they go out of quality, and then goes from there. But that information is highly valuable when you start looking at your business processes and how effective and efficient they are.
Now, I think, if you've got the opportunity to, marry up your downtime tracking system with, appropriate set of, say, continuous improvement templates. So, for example, if your downtime tracking system is getting granular enough to say, why is this machine down? Is it, a fault? Is my robot OVC'd on its, wrist axis or something? Or, as much as like, is it blocked or starved, right? So, a lot of our downtime we measure when we get into like micro stops and things are not, not even the machine failing. Oftentimes in the maintenance world, we get fingers pointed at us. Why is that machine never available? Well, it is available. You're never giving me parts to let it run, right? And having that detail where you can say, hey, this cell or this machine is maybe its top 2 failure modes are blocked and starved. So it either can't push parts forward or it's not getting parts to make. So maybe marrying that up with like a theory constraints continuous improvement template, right? We can start looking at why is this blocked and starved? It might just be as simple as, hey, my line's running at 80 jobs per hour and this cell's running at 85. So it's pushing parts out faster than they can be taken. And it's pulling everything out of its upstream process as fast as they can supply. So, maybe the answer, just simply slow it down to meet the rest of the line. And then you watch your productivity go through the roof. But, having those templates for like focused improvement and theory constraints and lack of machine quality kind of templates available to then take that data and go make real change out on the shop floor that's kind of measurable and sustainable, I think really drive the power of that system through the roof.
Yeah, I would agree with that, with what you and Stan both just said. Is a number of years ago, we started monitoring about 100 NC machines in our factory. And I know that a few senior leadership folks were thinking, oh, we're going to just focus on getting people working faster and the machines working faster, and we're going to see all these improvements. And actually, what came down to what was killing us was the machines weren't running. And they weren't running for all the things you mentioned. The parts weren't available. There was no raw material. There was no operator, and actually those things were bigger factors than the downtime, or like preventive or reactive maintenance going on. It was just we weren't as well organized as we thought we were. And to your point about focusing on the bottleneck, using theory of constraints, I think that's key. Is you want to make sure that the bottleneck machine never goes down, right? You subordinate everything to the
Absolutely
to the bottleneck, because an hour lost on the bottleneck is an hour lost through the whole process. So, but just knowing the machines are up and down already starts to move you forward from wherever you were before if you weren't tracking things. So even a small step can start to get you on a great journey to improvement.
100% agree.
Yeah, and just to build on that, a lot of the reasons that we're capturing in these systems might be the first input from an operator or from a technician who gets down to the equipment. That might just be scratching the surface. Depending on the severity of the event or the duration, the impact to the process, it might be good to leverage those templates that you're referring to, Mike, for root cause analysis as well. Identifying which ones you really want to do more of a deep dive in, where they might say it was the VFD tripped or there was a broken bearing or something like that, and it stays there. But there is an opportunity to really drill down to the root causes of it. Was it materials? Was it stock? Was it something else in the process, or that was really causing that?
That's one of the biggest oversights I've seen personally is, a machine goes down and oftentimes, the technicians do what they do best is they get it running again, right? And oftentimes what I found is, the root cause is, this bearing failed. Well, okay, that's one why. How do we get to those 5 whys, right? To right. maybe the bearing failed because the shaft is out of alignment. Why is the shaft out of alignment? Because we've got this vibration. Why is there a vibration? You go all the way down the chain and you find out the actual root cause is really nothing related to just getting the machine back online, right? So 100% agree. You get going through that proper true root cause methodology that then drives into that continuous improvement. You just see like exponential improvements.
All right. Just for the sake of keeping things moving, we'll go to the next question. This one will be for Steve Richmond. Can you discuss the security and data protection measures in place for cloud-based maintenance software?
Sure. Thanks, Mario. I appreciate you having me on. Security is pretty broad and deep, but particularly from a cloud-based perspective, it starts initially with physical. Who has access to systems? Who has access to buildings? Who has access to data centers? All those things need to be pretty tight, whether they're biometrically controlled, key card controlled, however you go about it. But once we have physically secured systems, then it becomes an issue of access. And getting into a system is becoming a little more sophisticated today. I think anything broadly used today is going to ask for dual factor authentication. You're going to give it a password, it's going to send you a number to your phone, and you'll verify. But that really is only the beginning. That just means someone has entered the kingdom. They have access to certain things. Those are typically defined by the system that you're using. I'm a maintenance planner. I have access to job plans, labor history, equipment availability, et cetera. And watching, the behavior of people once they've entered a system is equally as important. You restrict people's access to certain data for a reason. And when you find someone that is trying to get outside of their boundaries, trying to access password protection or trying to access data that's beyond their means or responsibilities, this is something that a good system should flag and let you know about. Steve has access to the system and he's looking at things, or he's trying to look at things that are above his pay grade. And those type of analytical tools are available and should be utilized. Physical access as well is, the geo fence. I work in Little Rock, Arkansas. I picked a bad city for that one. And I'm always accessing from Little Rock. Well, all of a sudden one day I try to log on from the Philippines. A good system, even if it's dual factor authenticated, should pick up that I'm in the wrong place, and a flag should be raised and questions should be asked. Behavioral attitudes around what people do once they're in, and the ways that those things are restricted is very important. I often refer to it as peeling the onion. Someone might get through the first door, but they won't get through the second window, and they certainly aren't going to get through the third door. Just a matter of having good profile information and very good systems too. Most companies today are going to have some sort of an ISO cert around security, and just obtaining that's going to give you some comfort level in that they have the right systems in place to protect who is gaining access and for what reason. The other thing is the second part of that was data security. First of all, I'd caution everybody to make sure that the data you're trying to secure is worth securing. If you've got a database full of bearings and fan belts, I'm not sure that that's critical to anyone's livelihood. At the other end of the spectrum, there are very many incredibly important things. Engineering drawings, patent applications, all the things that go along with pharmaceutical or engineering organizations. And those things need to be very carefully monitored as to who has access to them and when. And again, maybe it's dual factor authentication, and sometimes it's dual signature security. Steve Richmond wants to look at these engineering drawings, and someone above his pay grade has got to authorize that. That's all process driven stuff, but it's a matter of keeping things as secure as they need to be, given their viability and how valuable they are to the organization. Anytime data is on the move, if you're moving data from point A to point B, it should be encrypted. There are various levels of encryption. The higher you encrypt it, this think of it as a piggy bank. It's going to be the more expensive it becomes. So moving data in encrypted formats pretty much a norm today. Encrypting data at rest is another common request that we see in RFPs. And what we find typically is that it's not a practical financial offering. It's too expensive to encrypt data at rest. So if you've got something that important, then you need to think about other methods as well as at rest data encryption. Again, I go back to the bearings and fan belts. Nobody cares, so why bother?
I'll go on to the next one. We do have two questions from the audience, so I want to get to those. But let's go to Stan. Can you discuss the main areas that significantly impact an organization's profitability and how software can help increase profitability?
Thanks, Mario. So we've talked about this all day, little bits and pieces of it, how we can maximize our return on investment from our software, whether it be through a CMMS or whether it be through IoT, security, and other areas. But there's actually 5 main areas that maintenance has a direct effect on profitability within a manufacturing organization. And most companies don't think about all 5 or think about the impact that these can have. So when I'm going through this, these 5, I want you to think about who's responsible in your organization for each one of these different areas that we're talking about that maintenance has a significant impact on profitability. Well, the first one's equipment reliability, right? Product throughput. We've talked about that most of the day today, right? And that's usually run by maintenance or production. They have the responsibility to see that the throughput is there. What most companies forget about is that I can increase my throughput, but my throughput improvement, my equipment reliability improvement should be linked to my sales side of it. If I'm in a true lean like Toyota, where I'm selling the car before I actually build it, I don't have to worry much, right? Now I'm worried about the uptime becomes even greater because now I've got a sale and I've got my profit margin set and we've got to get it there. But if you're in a organization that's transitioning from an old pull or push system to a pull system, you really need to link your equipment reliability strategy with your sales so that you get the right impact and you got the ability to actually sell what you're making. The other area that we focus in on is dealing with maintenance efficiencies. Now we talked about that with maintenance planning and that. One of the things that software and AI and ML allows us to do now is you can actually see and get all the information out of your EAM and ERP systems now to truly see how each of your maintenance business processes is actually functioning. You can see everything from the time you put a purchase order in and a request in on a work order, right through to it's received, goes in inventory, used on the work order. You can now monitor and get a full viewpoint of all your scheduling and planning. So there's huge opportunity here. And this is one that we all know, right? I've spent 30 years implementing cultural change management, and I started in that field as a CBM expert, right? But I learned really quickly that I can put the software in, I can put the sensors in, I can get the algorithms in, but you know what? Nobody could react because minus a part. I don't have the right experience. I don't have the right plan. It's not available when I need it to get it out and get it fixed. So one of the things I learned very quickly is with maintenance efficiency and any type of software is that you have to focus on the basics, and that's your maintenance efficiency, business processes and procedures. A third area that companies think about, but they don't truly understand because it falls under a different department, and that's my MRO and procurement. Now that usually falls under finance or under procurement or under maintenance, depending on the size of the organization. But very few companies truly understand how much that part sitting in that bin actually costs them. And that's a huge opportunity that, when you're doing equipment reliability, when I used to do the CPM, I'd look at maintenance efficiencies and I would lower the inventory levels to match. And that was my return on investment because that's instant. Whereas my CBM systems can take a little bit longer to realize the investment. So that's a third area. A fourth area, which is becoming more and more prevalent, is human resources. That whole area of human resource falls on human resources. Maintenance usually doesn't have a huge impact on it. However, it's a big impact to the efficiency of maintenance. Getting the right person with the right skills at the right time. And the last area that maintenance has a direct impact on is mitigating risk. So you think of all of our different systems, and this is dependent on your organization or your company that you're working with. We have environmental risks now. Just look at the train derailment that just happened down in the US there, right? We've got safety, we've got legal, we've got image, all these other areas. If our preventive predictive maintenance program is not working properly, we're putting the company at risk. Even worse, if our PM program is static and we have a false sense of security that our PM program is actually working, now think of the hidden risk that's sitting out there to the organization due to mitigating risk. And these are all things that can be resolved now with software. There's tools on the market today that will look at each one of these, tell you exactly where your PM program is working, not working, tell you how your inventory and how to level it so that procurement, inventory, and maintenance are all in sync and all shooting on the same cylinders and moving forward. The second part to that question was how software can increase profitability. Well, there's a very short answer. A software is a tool. It cannot add ROI. It is the people that use that tool that add your ROI, right? The software has to link and give the right information, the right evidence, the right knowledge, and an action item to the person at the right time. The right information, and the person must be willing to accept it and act upon it. That's what builds our ROI in software. And that's a huge piece that, you know, you look at the various aspects of how do we get our return on investment. It's getting the people involved, using the tools, and you'll get a huge return on investment. Now, maximizing your investment now, one of the nice things about what's happening in the world today with all the different issues with artificial intelligence, machine learning, and IoT, is companies are investing in all these different platforms. And we've got all these different areas that we have to improve. What's beautiful right now is you're starting to see a base of data that's being used as a base. And then what you see is an algorithm coming up into maintenance to help improve. That's in sync with inventory, that's in sync with HR. So even though they're under different silos, you can truly start to see now that everybody's in sync and moving forward with the same information at the right time. That's a huge win that we haven't seen in years past. But that's what we're starting to see now is you've got your predictive, you've got your descriptive, which looks at all your human interface and that through AI and ML. You've got my HR, you got my procurement, you've got my supply chain management. All that data is coming together in one bucket. And then that data is being used to drive the entire organization forward in the different areas in a consistent base to allow for maximized ROI on your investments. And the nice part is those type of setups don't cost a lot of money because they've already invested in a CMMS. You've already invested in predictive. You've already invested in HR. You've already invested in all these other areas. It's just pulling it together. And now you maximize on your current investment for a minimal of the price that you would think you have to put in. So it's a beautiful way. There's really exciting times when we're dealing with software right now in the maintenance world. We've never been in this situation before. Well, actually we have. When we went in the old 1980s from handwritten to the CMMS coming out, that was a huge revolution. Now we're in that next phase, finally, where we can start to utilize all of this data coming in and get the entire organization moving forward and truly improve maintenance as a whole with the use of software.
All right, thank you. Anyone want to quickly weigh in? We do have two questions from the audience, if not. All right, so I'll go to the questions. The first one is there any data on whether SaaS model CMMS is less expensive on premises in the long run? I think Stephen mentioned that he'd wanted to answer that one.
Yeah, I'd like to answer that question. So it depends how you look at it. If you just look at the cost of the software, then the SaaS model is always more expensive because you're paying for it as long as for the life of the product, as long as you use it. If you buy something with a perpetual license over the long term, it looks cheaper. If you're just looking at software and the maintenance cost, especially if you don't upgrade it, and a lot of companies do that with some of their bigger systems, they just stay at a certain level. But then you got to look at the total cost of ownership. So if I buy it because it looks cheaper because I'm buying the software up front and I know exactly how I can calculate, the payback period or whatever finance is asking for on that, then I need a server for it. I need a database server. Then I need people to maintain it and upgrade it and version upgrades to both the software, the database, and the operating system. So you have to look at the total cost of ownership, and you've got to decide, is that a business I want to be in? I think, and we've seen it over time, people are trying to focus on their core business, and running computers is not what's core in a manufacturing world. That's more of a distraction, especially if it goes down. So I think you have to look at the whole picture and decide if you really want to, what business are you in? Certainly, if you want to run the system in-house, you can do that. But let's just acknowledge there's a cost that has to come into that total cost of ownership picture.
I'm pretty passionate about this topic myself. Frankly, I think purchasing, owning, and operating software is a fool's errand. There's absolutely no way those numbers ever make any sense. You should be looking at the utility of what it is you're trying to do. A service will trump a product every time. And there's tons of data out there if someone wants to go on a search for it around that sort of thing. Where you really go south on cost is the operating and maintenance over time. Just the information security side, upgrading all the different tools that Stephen mentioned, the database, the middleware, the operating systems, the application itself, just keeping up with that stuff. There's just absolutely no way you can do that internally anymore and have it make any sense. Opinion.
Okay, I'll go on to the next questions because we're running a little bit late, but I want to keep the conversation going. What is the most important step not to miss when implementing a CMMS? I believe Stan said he wanted to start on that one.
So this one is near and dear to my heart. I get really, really upset when we introduce a new CMMS system and we throw out all of our previous history. Because our history is there, and that's what's going to drive us in the future. Now, there's certain equipment, right? If you're going to get rid of your equipment or the equipment's gone, the history's no good. But if that equipment's still got 5-10 years of life left in it, and it's been around for 5 or 10 years, you need to pull that data into the system because it's a value going forward. It hasn't been up till now, right? It's been there, and there hasn't been a lot of ways of analyzing it, right? A lot of data in, but no real nice way of getting it out. But now with the new technology that's on the market, that data is readily available and hugely valuable. So by keeping that data and that history, taking the time and the extra money to transfer it into your system, and it doesn't, there's ways there's systems out there, SaaS systems that will allow you to absorb their data and you can hold it for doing certain experiments, certain machine learning models with it or when you need it at a reasonable price. But that is one of the key steps in implementing a CMMS that I see almost everyone misses, even when they go from one system to another. Like the Advantage Pro right now, right? A lot of companies are trying to move away from that because of the issue going on there. But they're only keeping 1 year data or 2 years worth of data. Wow, what a waste. You got to pull that data in. That's the most important thing when you're implementing a CMS. Get the right data in at the right point in time and get your history in going.
I'm just going to add a little bit to that, and this is going to sound overly simplified compared to your answer there just a second ago, but like thinking of the scenario where maybe you don't have history, maybe it's a new shop, or you're just kind of transitioning into a CMMS for the first time. You really don't have those historical records. and you're really starting out green. This is going to sound, again, overly simplified, but really thinking about your asset hierarchies. When we build, say, the asset trees in your CMMS, right? So like what I get asked all the time from customers for help on is, I want to see the total amount of downtime on this line, right? And then I go in and kind of have a look at how they've set up their CMMS, and it's like, well, you don't have any parent-child relationships between any of these assets. It's just an entire list of assets. And I don't know that robot 1S3 belongs in your sealer line, like to really think that through so you can say, and again, getting back to the Pareto model of the stratification of data, right? Like, so you can say at the director level, what site is my worst offender. If you don't have that tree built, between your sites, you can't really segregate the data that way, and all the way down, right? You get down to the maintenance supervisor, the maintenance manager saying, go fix the worst asset on the line you're supervising. Well, what is that, right? And if you don't have that structure, you can't say, okay, here, here's all my assets on this line. What's the worst offender, right? So to really think through the hierarchy of how your machines fit into the CMMS, the parent-child relationships, and as well as coding, right? Like this is something I think that's overlooked quite often too, is, not just naming the machine, but, oftentimes we give it like a code, give some thought around the code around, do you want some sort of naming structure that if someone were to just look at that, they'd roughly know, which column to go to, what type of machine is it a mechanical asset or an electrical asset, kind of think about the naming structure or the coding of the machine just to kind of help down the road to kind of segregate data. Right in the beginning, you don't have a lot of data, so that's not super important to you. But a year down the road, when you've got all this data and you think, great, I've invested in this CMMS, we want to look at our historic data and we want to do better. If you don't have that structure in place, it becomes exponentially more difficult to put those charts together.
All right. Anybody else want to weigh in on that one? This will be our last questions as we've gone over time.
No, I think Mike hit the nail on the head, and I was smiling because it was a mistake I made in an earlier life, and we had to go back and redo things. We had 5 sites in North America, and we were, trying to figure out how to name things and relate, like even down to HVAC and other systems in the building as well as the assets. I think the answer to your point, though, is it's not the name or the specific key record identifier you give, it's the metadata. I work with a lot of companies around metadata, and that's the key. And the systems usually give you lots of fields. People just don't. I think maybe there could be a failure maybe on the implementation in some cases, that people don't explain how important that is and how to use it and how to think about it. But to your point, maybe you have to live with it a little while to understand the relationships and then build them up. But for sure, I'm helping people with 4- and 5-year-old systems go back and fix metadata so that we can do the analysis based on that treasure trove of data. And I think everybody's mentioned the fact that the data is the gold. That's the treasure.
And it's interesting, we do the same. We're helping companies with we have tools designed that will allow us to do it electronically, to marry it to help with the various, especially when you get into linear. Because if you got an older sister set up on the old parent-child, and now I've got a relationship linear and that. So there are tools out there that can help you very cost effectively to redo your hierarchy. But it is an extremely important, Mike. Good point that you brought that up.
Appreciate that.
Okay, and with that, that brings an end to our panel discussion. Thank you, Stephen, Stan, Steve, Michael, and Matthew. I'll say that 5 times fast. Great conversation, everyone. Thank you again.
Appreciate the opportunity to be involved.
Yeah, thank you, everybody. It was great fun and a pleasure.
Yeah.
Thanks a lot, Mario, for organizing it, and thanks to everybody for participating. Had a great time.
Thank you very much.
Thank you. I would like to thank all of our attendees for joining us today. In the meantime, be sure to visit mromagazine.com or any of our MRO social media channels, whether that's Twitter, LinkedIn, Instagram, YouTube, or Facebook. Once again, I wanted to give a big thank you to our sponsors who are an integral part of this event. Once again, our gold sponsors are Asset Watch and TMA Systems, And our bronze sponsors are Fluke Reliability and TRO. Don't forget to go to our event website to see a selection of product demo videos.